In this video, we're going to be talking about identify are increasing, decreasing, what's their minimum, maximum, where it occurs, what exactly it is. A function, the first objective is identifying intervals on which the functions are increasing or decreasing. The function is increasing on an open interval I if the function at the beginning x value is less than the function value at the next x value. So that is, this x sub 1 is less than x sub 2. So let's say this would be x sub 1 and this would be x sub 2. So that x sub 1 is less than x sub 2. And if that's the case, if I'm looking at in this direction, in increasing direction, if the function value at the first x is less than the function value at the second x, then the function is increasing. And the definition for decreasing is if again I go x from small to large, if it happened the y value for the beginning x value to be larger than the function value at the next x value, then we say the function is decreasing on that interval. And of course, if for two values the function has the same value or the y value is the same, then we say the interval is constant. So I have here two examples, graphs that we worked with before. Use the graphs to determine the following: intervals on which the function is increasing, if any. So probably the best way to approach this problem is to find the coordinates of the basic points, minimums and maximums. The top points, like here I can see that top point here would be at x is -5, the y value would be 3, and then I can see the next here at x value being -1, the y value is -4. And let me flip it a little bit because it's not well visible. I'll put it here. Then another like top value here is gonna be when x is equal to 2, the y value to be 5, and then the last one when I see as minimum value here is gonna be when x is equal to 6, the y value to be -3. So where is the function increasing? I'm gonna underline the function, that's the pieces of the function that the function is increasing over. Here I'm gonna make it a little bit darker. Everybody think that this is where the function is increasing. I should have probably picked a different color. Let me do that. You make it red to be easily visible. So I can see that this is the piece of the graph where the function is going up. So the function is increasing at this interval. Well, the interval is not going to be the y value, but rather what this question is, for what x this happened. For what x this is happening. And I can see that x begins from -1 and ends at 2. So for x between -1 and 2, the function is increasing. So the question, for what x the interval, the function is decreasing, I'm gonna look at the pieces where the function drops. Here the function drops at these pieces. But again, I'm not gonna be interested in the y value, but I'm gonna answer for what x this is happening. So you need to understand and memorize that these questions about the function value we answer in terms of what x is, so that this is happening. And I can see that at the beginning x is -5, and this first part between -5 and -1, the function drops, and there is an interval of increasing, and then starting from 2 up to x value 6, the function also drops or decreases. So we use a union sign in the middle, showing that from both of those intervals x, the function is increasing. And constant value, we don't see any constant values here, so I would say none. For this graph again, and as in the previous lecture, I'm going to make this full dot here to be able to recognize that -1 is included in the graph. And I'm going to put the coordinates again. So this coordinate here is going to be -1, 2, and then that coordinate is interesting here because it looks like that's the maximum value. Here that's 0, 3, and there is no other minimum or maximum value here. So when the question is for what, determine the intervals on which the function is increasing, if any, I'm going to think, okay, so where is that happening? Oh, this is where it's increasing. And again, my answer is going to be in terms of x. Oh, x needs to be between -1 and 0, this to happen. X is from -1 to 0. And I purposely put x here so you know what I'm talking about. I'm not talking about points, I'm not talking about y values, I'm talking about what is x, so that happened. Interval on which the function is decreasing, if any. And again, I'm gonna take the beginning value for x where that happened, and that looks like 0. And notice that this function would keep dropping. It keeps dropping to infinity, and x grows to infinity also for this period of function decreasing. So x is going to be from 0 to positive infinity, the function to be decreasing. And I don't see any constant intervals, so there is none. The second objective is going to be locate relative maxima or minima. A function value f of a is a relative maximum of f if there exists an open interval containing that x is equal to a value such that f of a is larger than all fx around a not equal to a. And the same relative minimum lesser than of all of other y values surrounding b not equal to b, then I would say that's a relative minimum. So we may notice the difference here between how it is in a relative maxima and relative maximum. The maxima is plural of maxima, so that's the difference comes from. So again, probably it's handy to just write the points, -5, 3, -1, -4, and then put it on the right place. Then 2, 5, and then 6, 3, -3. Now, point -5, 3 is not included in the graph, so I'm not going to be considering that as a point from the graph being minimum or maximum, because there is that empty circle. This point is not part of the graph. So out of all rest, I'm going to consider find the numbers, which is find the numbers is what's the x value. Find the numbers, which is what is x. For which f or for which y has a relative maximum. And we see that at x is equal to 2, there is a maximum value of y is equal to 5. So where this happens, it happens at x is equal to 2, the maxima itself, or maximum, is going to be exactly f maximum is going to be equal to f of 2, and it's equal to 5. The other question, find the numbers at which f has a relative minimum. Now, notice that this point right here looks lower than the other point. However, based on definition, a relative minimum or relative maximum is going to be all the points that are the lowest in some interval. So I can see that both of those are lower than the points around. So I'm going to have two minimums here, two relative minimums. And at x is equal to -1, I'm going to have f minimum of f of -1, and the value would be -4. So the minima is -4. So that's the answer for the first question. That's the answer for the second. So here, that's the answer for what is the minima, and the minima is -4. And then the other one, I would say, for x is equal to 6, have another minimum. And this minimum is going to be -3. So these are relative. One of them I can see is the smallest one possible for this graph, but these are relative in particular area. Use the graph to determine, find the numbers for which f has a relative maximum. And just by looking, I can see that that's the largest point along this graph. So I'm gonna say a relative maximum happens when x is equal to 0. And what is the relative maxima? That's going to be f maximum, which is equal to f at 0, and this is equal to 3. Find the number at which f has a relative minimum. Notice that this function goes indefinitely down. So there is no absolute minimum value. However, there is a local minimum value here, which in this area is the smallest value, and I'm gonna use that as my relative minimum, and that's happen at -1, 2. So that's have relative minimum, relative meaning local, and that happen at x is equal to -1, and f minimum is f of -1 equals to 2. So my answer here is 2. We'll continue with the next objective, which is identify even or odd functions and recognize their symmetry. Now, a function is even function if we plug in a negative x every time when we see x in the function, and for all x's of the domain of f, and we receive exactly the same thing. So, for example, f of x equals to x squared. Notice that if I plug in a negative x, that would make negative x here, but this negative x is squared. So negative x squared is the same as x squared. I can see that f of x is exactly equal to f of negative x. So if that happens, we say, well, this function is even. What is valid for the even functions? They're symmetrical in respect of the y value. And how we graph x squared, if you remember, that's a parabola. And I'm gonna exactly show you what this means. So for x is equal to -1, the y value is equal to 1. And for x is equal to +1, the y value is also equal to 1. So if I plug in -1 here, I can see the result is exactly as had I plugged in 1. So Even functions would be symmetrical in respect of y-axis. What's going on with the odd functions? The odd functions are the ones that if we put negative up front of them, that negative is going to show up front of the function. For example, let's the function be f of x is equal to x cubed. If we want to do f of negative x, that's the same as negative x powered by 3. And that's the same as, that's negative 1 to the third is negative, and x cubed is x cubed. So that's the same as f of x with a minus up front of it. So that's the same with negative f of x. And if that happened, we say, well, that's an odd function. And what happened with the odd function when we graph as x cubed? There is a symmetry in respect of the origin. So how this look like is like, that's 1 and x cubed is equal to 1. But if I calculate x of negative 1, the result is going to be 1 with a minus up front, negative 1. So symmetry in respect of the origin. And here's a question. Determine whether the function is even, odd, or neither. Many functions are not symmetrical, and many functions are not even or odd. So, but the strategy would be replace with negative x and see what's gonna happen. And that's negative x powered by 5 plus negative x powered by 3. And since 5 negative signs would give me a negative x to the 5th, I'm gonna write that underneath. That's negative x to the 5th and negative x cubed. Notice that we can factor the minus sign. From both, and we would be able to recognize this function right here. So f of negative x is equal to negative the function of x, which means this is odd function. I'm gonna give an extra example. Let's check f of x is equal to x squared plus 4. If we plug in a negative x, we'll receive negative x squared. 4 doesn't change from negative x being negative x, so it's a plus 4. And f of negative x turns out to be x squared plus 4, which is exactly as the function itself. So for that one we would say, well, that's even function. And if neither negative f of x happened or f of x happened, then you say the function is neither. And I'm gonna continue with the next objective in the next video.